No, that's me starting the meeting on the laptop. It would be, there was a WAA email like 2 nights ago. It would be in there. Okay.
Okay, I'm in. Hold on a sec. Zoom link.
The WA. And just so you know, we're going to start the meeting now.
Hey guys, I'm not sure if you can hear us, but we lost sound.
Mike, are you hearing anything? Mike V?
No, sounds like
Yeah. Anybody hearing anything, guys? Ladies?
I'm not hearing anything either.
Okay, I think they just fixed it.
Can you hear us now?
Yeah.
yes, we can. Yep.
Oh, okay. So I was saying that we want to continue to use the mass because this is sort of a gift that Pace University gives to us to have this venue. And, you know, they don't need the trouble of people getting sick. So I think if we just show them that we are conscientious, that will promote them letting us continue to use the venue. So first announcement next week already, not this Sunday coming up, the following Sunday. Sunday I put in red because usually we do this on a Saturday. Sunday, May 22nd is our big club picnic. You have to be a member to go to the picnic. We have a lot of events you don't have to be a member, but this one you have to be a member. And we have a lot of great food, a lot of fun. We sometimes have like trivia contests and some solar observing potentially. But you need to, it's going to be at a different venue this time at Croton Point Park Pavilion in Croton-on-Hudson. And if you remember, you should have received an email announcement with the directions. There is a small parking fee, and there's a lot more detail in that. But the club brings the basics, hamburger, hot dog type food. A lot of members will bring a snack or a dessert to sort of supplement. But the basic food is purchased by the club. So that's why it's important to RSVP so we know how much food to buy. And Eva is sitting here in front row. You can either catch her after the lecture, send an email, or if you want to put in the chat, you could also put it in the chat if you're planning to attend. So I have a couple of pieces. I like to do a couple things of astronomy news. And I guess the theme is great telescopes, because the first we have an update on the James Webb, which, as everybody knows, is infrared telescope, 6.5 meter diameter mirror that was launched December 2021. First light, we showed this at one of the meetings, first light February 2nd, 2022. On the lower right side is the image, the first image. And when I looked at it, I was like, oh, okay, right. But now they've gone through 6 months of, you know, commissioning and calibrating and, you know, really getting things going. Not totally done yet, but they're giving us the first glimpse. First glimpse is on the right. The picture on the left is the same field through the Spitzer, which has been retired. And on the right-hand side, you can see how much more detail and clarity is coming through now. and they're not even done yet. So, you know, it's a sign of a lot of good things to come. And we have the second grade telescope. We have the Event Horizon telescope. This is a network of several very large radio telescopes that use this, they call very long baseline interferometer, by linking all of these telescopes around the world, including Chile, Hawaii, the South Pole, Arizona, Spain, and Mexico. By linking all of these scopes, it's the equivalent of one huge telescope. And the map here shows you where all these telescopes are located. Now, they had groundbreaking research that they announced April 10th, 2019. They did the first direct imaging of black hole, which was M87 star. So that was the first black hole with the direct imaging. Everybody's kind of, over time thought that they were there, but it's been a lot of indirect effects on surrounding stars that we've seen. But just yesterday, this was announced just yesterday. This is the Sagittarius A star at the center of our galaxy, the Milky Way. First direct imaging. And they said it was, I actually listened, I was supposed to be working, but I listened to the press conference instead. So, they said it was actually a lot more difficult to do this image because number one, it's a smaller black hole. It's still big, but it's a smaller black hole. And, they had to deal with all the stuff between us and the black hole within our galaxy. So a lot more obstructions. And they said, although everything is going around the same rate for the two different black holes, the fact that this one is smaller, things get around faster, they complete their evolution faster. And that apparently interferes with their ability to image, but they're able to work this all out. And so this is now, we have like this texting system in my hospital. So this is now my image. So this is what I look like at work. So I'm sure there are a lot of people that they thought I was crazy, but now they really know I'm crazy. So. Okay, so a couple of save the dates. June 10th is going to be Urban Astronomy with Maury Rosenthal. And I mentioned this last month. He's somebody who embraces light pollution, because he will go out in the middle of Manhattan and set up scopes and show an image and show people the deep sky. So he's going to be here now. Because we normally do not have meetings over the summer, but I thought that since we missed so many because of COVID, I'm trying to squeak in a couple more over the summer, especially because we don't know what's going to happen in the fall again. So I'd like to try to get some more meetings in while we can. So we are aiming to do a July meeting, but we have some approvals that we have to work through. And the July meeting, and if it's not July, then maybe August, is going to be about observing the 2023 annular eclipse with Charles Fulco. And so that should be really great. So keep your eyes open. We still have to work out some of the issues in order to get this meeting going. In terms of the star parties, we have May 21st, so the night before the barbecue. Yeah. So it's going to be your WAA weekend. And if we have bad weather, it'll be the following week, May 28th. With that, I'm going to have Bob Kelly come up to give the sky this month. Let me just get out of this.
Thank you.
Is this you?
Doesn't
No,
look
that's
like me.
me. That's
Doesn't look like me, yeah. Doesn't look like me. It just
Okay.
doesn't look like me at all. No resemblance. That looks a lot like me. Yeah, I know the feeling. Don't worry. No pressure. No pressure. Hi, everybody. You
Okay,
can't see,
there we
but
go.
I can see.
There you go.
Oh, thank you.
Okay.
All right. Thank you very much. I need talking to this
No,
or that.
no, the audience.
Oh, talking to the audience. Okay, well, that's good.
I think we got to share that screen in Zoom.
Mm-hmm.
I don't think it's
You don't see it?
You gotta zoom it, you gotta do that over there, don't
Yeah,
you?
no, do right where you are.
I don't see anything on the screen but my
Close
presentation.
that, minimize that.
Okay, yeah, I'm sorry. There we go.
Okay,
There we
share
go.
screen at
There
the
we go,
bottom,
share screen. Okay,
and then pick your presentation.
and pick the presentation. All right. Slideshow.
Is it on now?
Yes,
Let's try that.
there it is.
Okay.
Does everybody see the presentation? Okay, now try covering
Yes.
your left eye. Sorry, I'm not an optometrist, but I like to pretend I'm Frank Field occasionally. And that's, you gotta be really old at that one, right? Anyway, what's up? Hi, everybody. James is talking. Okay, that's not me. Anyway, so yeah, it's, by the way, there's a total lunar eclipse coming up. You may have heard about it, it was in all the papers. But on your way out, or if you like, even during my talk, if you want, I've got a whole bunch of bookmarks. All say the same thing when the times are the various aspects of the eclipse. This, I would suggest, especially if the weather is kind of problematic, and maybe you try to catch a little nap and something like that, put this by your bedside in case you want to get up and pee. I'm sorry, peek at the eclipse. Sorry about that, youngsters. It might be helpful. So feel free to take one, take a couple for your friends. All righty, so morning sky. Let's see, well, we actually blocked up there. Yeah, I have to remember not to write things up at the top. 30 minutes before sunrise, we've got Venus, of course, really bright, but really low, barely 10 degrees above the horizon, followed by Jupiter, Mars. Neptune, again, is trying to photobomb the scene. This month, it's going to do it with Mars originally. This is this weekend. In fact, of course, you won't see any of this because it's going to be cloudy all weekend, but, gives you the idea for the month. And then Saturn's way off over here. And if you look for Saturn really early, Vesta is right nearby. It's about 7th magnitude. So it might be worth a shot. So you could see Neptune and Saturn and Vesta and Jupiter and Venus and Mars would be a pretty good setup there. It'll get a little easier as the month goes on in a funny way, because Jupiter and Mars are going to line up right next to each other late in the month, around the 28th, 29th. So you want to try to get out for that. Now, an interesting thing is to get your telescope on each of these objects and see how they compare in size. Mars is closer, but is Jupiter still bigger? Is Jupiter brighter than Mars? Yes, but is Jupiter's surface brightness brighter than Mars's surface brightness? There's a lot of differences you can pick out with an ordinary telescope. There's the man of the hour. Fortunately, the 8 o'clock hour. Give me a few minutes.
I'll see you later.
No, don't leave. God, they'll never forgive me. In any case, so yeah, so later in the month, this lineup will be really cool. Now, this weekend also, another thing you might not be able to see, the International Space Station is going to do 5 shows a night. Going to be overflight. We're in that beta cutout where the International Space Station is up in the sun almost all the time on its orbit, when it's in this part of the orbit, because of course, as you know, the sun doesn't set up near the North Pole. So we're in that part of that orbit. Why it doesn't happen in June, it's complicated. I won't even try. Okay, but this is tomorrow night straight overhead around, actually this is tonight straight overhead around 9:58. So I don't think Joe's gonna run that long. So you might get to see this when you get home tonight. But if he does go that long, it'll still be better than seeing this, don't worry. Now, here's a cool thing that we're probably not gonna see. From 11:32 to 11:38, the International Space Station, and you see the lines here in the northwest here, and this little tiny line here where next to where my little arrow is here in the northeast, it's actually going to go into the Earth's shadow and back out again. So if you could see this, if it wasn't cloudy, check this again on heavensabove.com tonight if you want to do this, because small changes in the orbit can make a difference with this. But it would seem like it'd be pretty interesting to see, because as the International Space Station goes into the Earth's shadow, you get the same kind of thing we see with sunset. You might see it get very red. How far it gets into the shadow might depend. It might take longer to turn red and then turn the red off. So this could be really interesting. And this is the kind of thing you might want to look for as we have a lot of overflights in the evening sky after these 5 flights a night end on Monday. So it'll be the evening sky after that. And if you want to, and tomorrow night, if you want to try another interesting kind of thing, the International Space Station and the Chinese Space Station will be in the sky at the same time. They will not be anywhere near each other. They'll be on opposite sides of the sky. So run both the maps like I have here. The International Space Station will appear to pass near the moon, and so will the Chinese Space Station later on. Chinese Space Station is about magnitude 1. International Space Station close to magnitude -4 on this overhead flight tonight. So pretty bright. But this is kind of an interesting thing. People sometimes like to get pictures of both of them at the same time. Kind of a cool thing. And I wanted to point out that I can't even remember what I was going to point out. Okay, something else I was going to point out about that. But in any case, next Starway to Heaven, as Karen said, Saturday, the 21st, 8:12 p.m. sunset. Gets real dark, astronomical twilight, not until 10:09, but come early anyway. Still fun. See how early, see if Sirius is still up over the horizon. I think it's going to be gone at that point. It was a lot of fun last month seeing it just after sunset and sometimes just slightly before sunset. It was so bright, but it's always that bright. Last quarter moon will be up at well after midnight, and this map in particular, if you care, is 10 p.m. The backup date, the 28th, have some different parameters for that. And that's our show for this month. Any questions? Didn't think you would. So anyway, pick up a bookmark on your way out.
Can you see it?
Yes.
Oh, okay, so I'm gonna ask Pat to come and introduce our speaker.
Hello, everyone. Is this on? Okay. And welcome. Our guest this evening is no other than the one and only Joe Rayo.
It's a good thing there's only one.
His name is synonymous with having been the very popular meteorologist and science editor for Channel 12 News. Retired from the broadcasting industry, Joe's interest in astronomy continues to make him one of the most sought-after speakers. Although the recipient of many professional awards, nevertheless, we like to think that none could be more fulfilling than Joe's gift of instilling in his audience a sense of wonderment for the night sky. Please give him a huge welcome.
Yay. Thank you very much, Pat. This is a very special time for me. I'm going to remove my mask now so that you can hear me. Does this work? I don't even think this works. Doesn't matter. My wife says I have a big mouth and it carries, so I'm sure all of you will be able to hear me and hear what I have to say. It is a special moment for me because this is the first time in the United States that I've had a chance to do a talk in this way in about 3 years. I have been giving numerous virtual talks to civic groups and libraries ever since the pandemic began. I did actually give in-person 4 talks in person on a ship back in December. I was on a ship to Antarctica. They had asked me if I'd be interested to go to Antarctica to see a total eclipse of the sun. Well, we were there when the eclipse occurred, but we saw absolutely nothing of it because it was totally overcast. But we did see a lot of penguins. But I'm so happy to be able to do this talk live and in person tonight. I'm just wondering, before I get going here, I don't have a clicker in it. So what specifically do I do to advance the slides? Or
the mouse here. Mouse or this may work.
oh, okay. Or I even can use the space bar. I could probably use the space bar too. Okay, thank you. Thank you. I didn't realize that. I'm so used to sitting down by my desk giving talks. Now you may be wondering who the gentleman is behind me. In fact, maybe some of you know who this person is, because I feel that I should dedicate tonight's talk to him. This is his old stomping grounds. This is Dr. Sw3 Engelbrechtsson, who for many years was an adjunct professor of astronomy here at Pace University. More importantly to me on a personal level, I am still a member of the Hayden Planetarium in New York. When I got going with the planetarium, it was in 1986. But when I started going to the Hayden Planetarium, it was in the 60s. And in those days, when you went to the Hayden Planetarium to see a sky show, you didn't have what's happening now. When you go there now, you are quickly rushed into your seat, you sit down, and there's a 15 or 18-minute show narrated by somebody like Whoopi Goldberg, Harrison Ford, Tom Hanks. And once the show is over, and let me just say that the effects, the special effects that you get now at the planetarium are far better than anything that we had, 30, 40, 50 years ago. But it's kind of like the Disneyfication of the great Hayden Planetarium. You're in, you sit down, you're entertained for about 15 minutes, and then you're up and you're out and you're gone to the next exhibit. When I was a young boy in the 1960s or early 70s, and I went to the Hayden Planetarium, the shows were done live. And they were done by real astronomers, such as the gentleman you see behind me, Dr. Engelbrechtsson. And in those days, and I used to visit on Saturdays, the Saturday schedule was amazing. They had a show at 11 o'clock. They had a show at 1, 2, 3, 4, and 5. All the shows were done live for 45 to 50 minutes. That's how the length of the show. And after the show was over, then you could walk up to the huge console and chit chat with the person who ran the show and did the narration. And a lot of times when I got up to that console, they asked a question. This was the man that I often asked a question of. And in fact, in later years, in the 80s, we got to know each other very well, very intimately. We got to be good friends. When I joined the staff of the Hayden Planetarium in 1986, one of the vexing problems that I had was trying to operate the console, which looked like it had a billion switches on it, buttons, switches, whatever, in the dark while talking to an audience. And at one time I said, I'm never going to be able to do this. I can't do this. How can anybody do this? And Sw3 was my mother hen, so to speak. We used to give courses. That's another thing that's not done anymore at the planetarium. We had courses in astronomy, aviation, ground school, navigation, meteorology. I was teaching a course on stars and constellations. Sw3 was teaching a course on astronomy, and we both had decided that we were going to be in the dome, in the theater, on this particular night. We would bring both of our classes in, and then Sw3 would start off first, talking and doing his class, and then his class would stay, and I would step up and do my class. I told him that just before, and I said, you're going to have to help me. You may even have to do my part, because I'm still not really ready to do this with the Zeiss projector, the Zeiss 6 projector. To say I was nervous, I was nerve-wracked. So went into the dome with my class. They sat down, then door opens. Here comes Sw3's class coming in. I'm standing there in the console, waiting. Finally, I said, is Dr. Engelbrechtsson here? Is he gonna? And one of his students said, he said that he had to attend to something downstairs. He said, you go ahead and start. Uh-oh. So now I'm doing my class. I said, all right, well, I'll do my class first, and then I'm sure he'll be here for all of you who are in his class, whatever. Did my class precariously, slowly turning knobs and switching. Then it was time for me to finish, and I said, all right, and here is Dr. Engelbert. No, he's still not here. I said, so now what am I going to do? He said, well, can you do us too? Can you? I said, all right, what's the nature of the topic? And I did my best to cover it. And when I finished, there was a nice round of applause from both classes, my class and also his class as well. And I said, well, I want to thank you all. I wish that Dr. Engelbrechtsson were here. And all of a sudden I felt a tap on the shoulder. And Sw3 was in the technician's booth behind me. And he came up to me, he shook my hand, and he said, I told you you can do it. I told you. And it was true. that was my foray into the Hayden Planetarium. And again, I knew this man for many, many years, all the way until he passed on about 8 years ago. And now, and I'm hoping he's here. I think tonight we were to have Dr. Engelbrechtson's son, Joel. Is he in the audience? Joel, are you here? There he is, right there. And I told Joel, I said, you know, I want to dedicate the talk tonight to your dad, and if you can come down, I'd be honored for you to come down. And I'm honored that you are here. I thank you very, very much, Joel, for being here. Your father was a part of a dying breed. We don't have people like Sw3 Engelbrechtsson or Fred Hess or Ken Franklin or Tom Nicholson. These guys, as I said, they would go up there, they would do almost hour-long shows, many at a time. And to me, it's kind of like baseball now. You know, back 50 years ago, you had starting pitchers who actually threw complete games, you know, or sometimes they'd even go more than 9 innings, 10, 11 innings. Now today, you've got designated hitters who don't even take the field. You've got people who, you know, they throw 5 innings, you know, coach, Skip, I can't go anymore. I threw 5 innings a bit, you know, what is this? And the same thing today. You know, you don't have very many people anymore who can give talks for an extended length of time. In fact, what Sw3 taught me and what the others at the Hayden taught me back in those days in the 60s and 70s, I'm now going to extol onto you. A full talk about an astronomical subject, which should, by my clock here, should be done at about 9 o'clock. We're just past 8 o'clock now. So let's begin with this talk. Those of you who are subscribers to Sky and Telescope magazine may be aware that in the May issue, I have an article about the prospective new meteor shower that may appear at the end of this month. And this particular article is based upon a paper which I wrote last year. We'll talk about that a little bit later. The two people who are at the helm of this talk, there you go. On the left, you see Arnold Schwachmann, and on the right is Arno. How many people in their lives have met somebody named Arno? Arnold Schwachmann and Arno Wachmann. And they made a number of discoveries in the 20s and 30s. One of these occurred 92 years ago, almost to this date, on May 2nd, 1930. They found a new comet which was known as Schwachmann-Wachmann 3. They would eventually discover 4 comets. The 4th comet would be shared by another legendary figure in astronomy, Leslie Peltier. But the first 3 were Schwachmann-Wachmann, 1, 2, and 3. And this one was Schwachmann-Wachmann number 3. After an orbit was defined for this comet, a lot of excitement, a surge of excitement, because it was discovered that this particular comet would be passing relatively close to the Earth, 5,735,400 miles away on the 31st of May, to be exact. Now, the reason for the excitement is that comets don't get that close usually to the Earth, but when they do, usually they can become quite spectacular, or at the very least, quite interesting. Some of you old timers may remember almost 40 years ago, in May of 1983, we had comet Iris-Araki-Alcott, which passed through within 2.9 million miles of the Earth. That comet, in fact, was the second closest approach of a significant comet to the Earth. The first, Comet Lexell, back in 1770, came in at 1.5 million miles. Now, Iris-Araki-Alcott was not a very spectacular object, but it did get up to about 2nd magnitude. But the most interesting thing about this comet was it went across the sky, from one end of the sky to the other, over a span of like 2 or 3 days. If you looked at it when it was passing closest to the Earth in your telescope, you noticed that it was actually moving relative to the background stars. A friend of mine looked through a telescope and made the comment, "No, look at this. It's like watching the minute hand of a clock." And there it was moving right before our very eyes. On the night when it was closest to the Earth, I was at the Custer Institute out in eastern Long Island. When I got there and the sky darkened, Iris-Araki-Alcott was to the upper right of the Beehive star cluster in Cancer. When we called it a night a few hours later and the comet was getting ready to set, the comet was now to the lower right of the Beehive star cluster. That shows you how rapidly it was because it was so very close to the Earth. So not a spectacular object, but an interesting object. One that, well, as the headline here shows you, a brush with the stars. 13 years later, Yakotake Comet, Yakotake. We all remember that one, I'm sure. This was a spectacular comet. This didn't come as close as Iris-Araki-Alcock. It came within 9 million miles of the Earth, but it was an intrinsically larger and brighter comet. So bright, in fact, that it actually reached 0 magnitude. And if you were able to get away to a dark site, you were able to see the tail, which, well, was relatively faint. It was a blue ion tail, but you could see it go way across the sky. Sam Storch. Some of you may remember Sam. He's now down in Florida. Sam and I, we lived on Long Island. And on the night when this comet was due to get closest to the Earth, I said to Sam, I said, you know, we really ought to do something about this. Can't stay on Long Island. Why don't we go to someplace nice and dark? And so picked him up at his house in North Merrick, and I drove in my minivan to a little community up in Dutchess County called Hopewell Junction. And the skies were quite dark up there. And when we got out of the car, when we got out of the minivan and walked outside, there we saw 0 magnitude Yakotake right next to Polaris, the North Star, with a tail extending out from that comet for about 40 degrees in the sky. And I stared, both of us, we were looking in silence. And after about 30 seconds, I said to Sam, well, this ain't something you see every day of the week. And it wasn't. And in the places out west, like in the Arizona deserts, where the skies can really get dark, some folks were saying they were seeing 80 and 90 degrees of tail because they had a much darker sky and a much greater contrast of it. It's an amazing sight. You want to see an amazing picture? This is a picture that no one ever thought would ever be taken again. Here you see obviously the spire of the Empire State Building here. And if you look right here, right over there, there is Yakotake. This picture was taken from 29th Street and Avenue of the Americas at 2 o'clock in the morning. And yet, in spite of the tremendous light pollution that New York City is famous for, this camera person was able to stand there and take a picture of the comet through all of that light pollution. It was that spectacular an object, naked eye. And that's what everybody was getting excited about with Shwachman-Bachmann 3. In fact, guess what? I'm not going to call it Shwachman-Bachmann 3 anymore. I'm going to call it SW3. It's a lot shorter. Everybody said SW3 was possibly going to be an interesting or spectacular comet because of its close approach. But alas, this was a dinky comet. This comet was only about 1.5 miles in diameter at best. Didn't really have a lot of the volatile material that would make it a spectacular comet. It was mostly a gaseous comet. And the comet was not even visible to the unaided eye at its closest approach. The comet at its closest approach was no brighter than magnitude 7 and was visible only with good binoculars or a telescope. Not a very spectacular and attractive thing at all. But a comet is a comet is a comet. And observatories around the world were aiming their sights on it. Here is, of course, the famous Yerkes Observatory Refracting Telescope, which is 40 inches in width, still the largest refracting telescope in the world. And on the staff back then in the 20s and 30s was a gentleman who was very interested in the small bodies of the solar system, comets, meteors, asteroids. He immigrated from Belgium to this country. His name was George Van Biesbroek, but his friends knew him simply as Van B. So there's Van B at the eyepiece of the Yerkes Observatory telescope. Now, can you imagine? I know some of you probably have big telescopes, big Dobsonians, 12 inches, 16 inches. I know a guy on Long Island, John Vogt, who actually built a 32-inch Dob. But can you imagine on any given night of the year when it's clear to have open and free access to the 40-inch refracting telescope at Yerkes Observatory? That's what Van Biesbroek had access to. He took pictures of the comet a couple of weeks before it got close to the Earth. He saw the coma of the comet, which that's not 10 feet, that's 10 arc minutes in diameter. So the comet was about 20 arc minutes. On the night when it was closest to the Earth, May 31st, 1930, Van Biesbroek, Van B, said that that the nucleus of the comet looked like an edge-on spiral galaxy, a spindle-shaped body, which John Bortle, a very famous comet expert, said, this may very well have been the very first sighting of the actual nucleus of a comet. Again, this comet came very close to the Earth. That night, Van B had apparently very good conditions. He had the biggest telescope in the world. So why not? Why not? Now, after 1930, the comet was missing in action for quite some time, a half a century or thereabouts. These are the presumed dates of perihelion. These were calculated recently as we look back on the comet. But all these years when the comet swept close to the sun, and the comet's period was about 5.5 years, all those years, the comet was missed. Nobody saw it. 1974, then in 1979, we got a brief glimpse of it. We picked it up after about a half a century. But then in 1985, it was gone again because the apparition was very unfavorable. It was placed very close to the sun. Why was it so difficult to keep track of? One, we already said it was a dim, faint comet. Two, we have to blame this big guy, Jupiter. Jupiter, biggest planet in the solar system, 11 times larger in diameter than the Earth, 1,300 times more massive than our puny planet that we all live on. But Jupiter, every time this comet was in its vicinity, Jupiter would say, hey, come over here, and would grab on it and pull it. Not a whole heck of a lot, but enough to pull it off its predicted course. And not only does Jupiter do it to this comet, it has done so with about 400 other comets. In fact, they're all located somewhere in between the orbits of Mars and Jupiter. And we know these comets as members of Jupiter's family of comets. Well, Sw3 was a card-carrying member of this family. And so that's why every time we thought we had, a good idea as to where it was, no, Jupiter would say, no, I'm going to pull you this way. I'm going to pull you that way, this way, and that way, and that way, and this way. Now, this is very important to consider, that this little puny comet is being pushed around by Jupiter every so often when it was in the vicinity of Jupiter. Now, in 1990, the comet came within 30 million miles of the Earth, and we finally got a good, long look at it. It was the best apparition that we had of it since the 1930 apparition that Van B and Schwachmann-Wachmann saw of it. So we got a good idea about its orbit. We got a good idea as to what it was doing out there in space. Then 5.5 years later, in the fall of 1995, the comet was coming back. And we thought, all right, it's coming back, no big deal, little comet out there. What you see on the screen here is just outside of the Paris Observatory in France, the Nankai radio telescope. And the Nankai telescope was looking at comet SW3 in September of 1995, and they began to notice something interesting. The gaseous emissions from the comet were starting to increase quite rapidly, in fact. And in fact, those of you who remember your high school chemistry, the hydroxyl radical especially was spiking, so much so that it was spiking to about 1/10 the amount that Halley's comet shows. And Halley is so much bigger than Schwachmann-Wachmann 3, but yet this comet all of a sudden was spewing lots and lots of gas. And then it started to get bright, much, much brighter. Now, it was not expected to get much brighter than 12th magnitude, 12th or 13th magnitude. But suddenly, observers were finding it at 10th magnitude, and 9th, and 8th, and 7th. And now it's brightening so rapidly that the Central Bureau for Astronomical Telegrams decided that they would have to issue a special finder ephemeris and an alert to everybody about this comet. The Bureau, they said, has received numerous reports from observers worldwide of independent discoveries of this comet, which has continued its remarkable outburst in brightness. And the comet was getting brighter indeed. 6th magnitude, 5th magnitude. Now, look at this. The comet was visible to the unaided eye. You didn't need a pair of binoculars. You didn't need a telescope. There it was. Now, can you imagine? There you are. You finished your work day, or maybe it's a weekend, and you say to yourself, I'm going to go get out somewhere where it's nice and dark. I'm going to spend my night under the stars. It gets dark. And as it's getting dark, you set your telescope up and you start looking around and seeing, okay, there's Vigo over here, and Sirius is setting in the west there and there. And all of a sudden, I'm like, wait a minute. What the heck is that? What is that? and you take your binoculars out and you look, you say, damn it, it's a comet. I didn't read about a comet in Sky and Telescope this month. What the heck is that in the sky? Or astronomy? And then you go on the internet quickly on your laptop to see, is there a comet, a 5th magnitude comet in the sky? No. What the heck is that? And all of a sudden it comes to you, my God, that's a new comet. I discovered a comet. And then you immediately, send an email to the Central Bureau for Astronomical Telegrams, or you call them up, or maybe even, for goodness sake, you send them a telegram. I discovered a comet, and you give them the positions. But no, this was not a new comet. This was SW3 at a distance of 122 million miles, 25 times further away than it was when it was right up next to us in 1930. We couldn't see it in 1930 without a telescope. Here it is now 25 times further away, and it's plainly visible to the eye. It's over 400 times more evident than it was way back when. What's going on? One of the foremost comet hunters of the day, who lives down in Australia, is Terry Lovejoy. And Terry Lovejoy's report was really an eye catcher. He wrote, it looked like a mini Halley. Its coma displayed a striking parabolic outline. Its tail was so intense in its first half degree that the ghostly glow was evident even through horizon haze. Amazing. Well, what happened? Well, maybe it went through an outburst. Comets do that from time to time. Every so often, a fissure might open up on the nucleus of the comet, allowing volatile material to escape. And if there's a lot of it, the comet, will go up in brightness by a few magnitudes. But that was not the reason why SW3 got so very bright. People were noticing with time that the coma was looking sort of bloated. And then suddenly, in early December of 1995, poof, not one, not two, but four nuclei suddenly appearing. So from September to December, this comet was undergoing a massive change. A change first in the venting of gaseous material, and then dusty material. Tremendous expulsion of dust had to have occurred to allow the comet to become so bright as it did. And then finally, boom, the comet just broke apart into 4 pieces. Comet came back in 2001, and we saw at least 3 major parts, but the return of 2006 was going to be exciting because the comet was only going to pass 7.5 million miles from the Earth. And did I say comet? I should say comets, because now it had gotten to the point where so many pieces had broken off that now they were alphabetizing the comet. Each fragment, this might have been fragment B and C and R and E and S, and and this whole mass of material was passing right by the Earth. Well, we had 2 observatories out in space. We had the Hubble Space Telescope that got the first crack at this comet. And then after the Hubble was done with it, the infrared eyes of the Spitzer Space Telescope would look at it. So here's Hubble's view of it. Here are 3 of the fragments, R, G, B. But then we zoomed in on each fragment. And look at this. Each fragment was breaking up in its own right, breaking up into its own smaller particles. Pretty amazing. Look at that. All of those pieces coming off of one single large fragment of comet SW3. And then, as I said, we looked at it with the Spitzer Space Telescope. And look at this. We have large pieces here, little teeny pieces here and here and here, more large pieces over here, and they're all aligned. Look at this. All along the orbital track of the comet, there are even smaller particles that have been ejected out into space. This is pretty amazing. The comet is literally falling apart. Well, now, here's the orbit of the comet. Again, 5.5-year orbit out near the orbit of Jupiter when it's farthest from the sun. But then as it swings around in its orbit, look at this right here. See that? This is our orbit, the Earth. We're going around here. Here's the orbit of the comet. And right there, right around the 30th or 31st of May, that's where we don't quite intersect, but we come awfully damn close to each other. The orbits come very, very close. And now, seeing that, and with the comet now breaking up into pieces, now comes the big question. Is it possible that maybe this thing will produce a brand new type of meteor shower? And we have a precedent for that. Yes, all of you, I'm sure, are, have at your home base books on astronomy. Open any good book on astronomy. Turn to the comet section and you will see this comet mentioned. This is Comet Biela, discovered by Wilhelm von Biela in the 1800s. In 1842, Biela did a very interesting thing. It split, not into 4 like SW3, but into 2. And now we have twin comets. 1846, we saw 2 comets. They came back in 1852, we saw 2 comets. We expected them in 1858. What happened? Nowhere to be found. And then there was going to be an exceptionally good apparition for this comet in 1865. What happened? Again, missing in action, no comet. And then came the big surprise. In 1872, the Earth was due to pass right near the orbit of the now deceased Comet Biela. And of course, we assumed that Comet Biela, because it wasn't seen in 1858 or in 1865, must have fragmented into many, many pieces. And now here comes the Earth on its orbit around the sun, coming to that near intersection point with Comet Biela. And on the night of November 27, 1872, this unexpected sight appeared in the sky. The Andromedan or Bielid meteor shower. The Andromedans because, well, the meteors seem to fan out from the constellation of Andromeda, or some named it after the deceased comet Biela. They called it the Bielid meteor shower. Totally unexpected. And there's a sad story related to this, and it involves one of the greatest astronomers of the late 19th century, Camille Flammarion, the Carl Sagan of France. Flammarion wrote many astronomy books. He was highly into astronomy. He was a popularizer. He loved talking about all facets of astronomy. And on this particular day, November 27, he had just arrived in Italy because he was going to have an audience the next day with Pope Pius IX. An audience with the Pope. That shows you how high up on the scales of importance Flammarion was in terms of science and in terms of astronomy. When he arrived in Italy, and I guess he took the train. I don't think there were any air flights from France to Italy in those days, 1872. But I'm sure it must have been a long, arduous trip. When he got to the place where he was staying, he said, the long trip, I'm going to see the Pope tomorrow. It's going to be a big day. I'm going to visit with my good friend at the Venice Observatory, Father Secchi. So I'm going to go outside. He stepped out on his balcony. He said, I watched the sunset in a beautiful display of orange, purple, and gold. The sun set, the sky began to get dark. And then that's when the greatest astronomer of his day, Camille Flammarion, decided he was going to go back to bed and watch the Inside the Eyelid show. Totally and completely missing what was happening that night. The next day, when he went to first the Vatican Observatory to speak with Father Secchi, you can just imagine how he felt when Father Secchi said, we had an unbelievable meteor shower last night. And Flammarion said, well, how did you find out about it? And Father Secchi said, well, I was having my evening meal here at the observatory. And all of a sudden I heard a knock on the door. And I went to the front door and I opened it up and there was this gentleman I never saw before in my life. And the gentleman bowed and he said, pardon me, Monsignor. He said, maybe you can tell me what is going on. He said, what's going on, my son? He said, could you tell me why the stars are falling out of the sky? And Father Secchi looked out. And for the next 4 hours, Father Secchi was out there making and taking observations of this amazing spectacle, this spectacular meteor shower. He counted, according to Flammarion, 33,400 meteors in the span of 4 hours' time. And if that wasn't enough for Flammarion, when he had his visit with the Pope, the first words out of the Pope's mouth was to the illustrious astronomer, so, did you see the wondrous showers of Diana, the goddess of the sky? And what do you think, Flammarion? When he wrote his memoirs before he passed in 1910, Flammarion said, this was one of the bitterest disappointments of my life. I can never measure the disappointment of missing out on this amazing display of shooting stars. Well, with SW3, we had thought actually that maybe there might be a meteor shower back when it was first discovered, because of the closeness of the two orbits of the Earth and the comet. Somebody in Japan said, maybe there might be a meteor shower with this comet as it passes close by to us. And indeed, there is a report on June the 10th, 9th and 10th, the 9th and 10th of June in 1930, that there was a report that meteors fell at the rate of 60 to 70 per hour. There's a problem, though, in this report. And I'm amazed that some technical papers actually took this report as it was and didn't do a little bit of investigating. Took it for its word. There was only one person, count them, one person who saw this so-called meteor shower. That was somebody who was in Japan at the Nissan Observatory. And the director of the observatory said almost apologetically, well, he's got very sensitive eyes. He said that because the meteors reported by this gentleman at the observatory were on average magnitude 5 to magnitude 6. He must have had a pretty dark sky for him to even perceive that. Now, I can understand. I could believe that to a degree. I know a guy, how many of you know Alan Seltzer, who worked at the Hayden Planetarium many years ago? Alan had amazing eyesight. He could see the moons of Jupiter. He could see the crescent of Venus. He could count 18 stars in the Pleiades, all without optical aid. The late George Logie, who did the Centerfold of Sky and Telescope, and we were visiting him once, and we actually said to Alan, Alan, you're BSing us. We don't believe it anymore. And he said, oh, I actually see that. I said, okay, we're going to challenge you. This was thought up by George. He said, we want you to read the New York Times from a distance of 20 feet. And we paced off 20 feet. Alan was at one end of his office. We were at the other. And just as Alan was about to read, I said, wait a minute, hold on. He may have read the paper this morning. He may know. He said, let's go to something he doesn't know. Space, sports, baseball. We had him read a story about the Yankees. All right, Alan, read this from 20 feet. All right. Well, yesterday, an amazing day at Yankee Stadium when Don Mattingly hit 2 home runs, knocked in 3 RBI, Alan. And he did it. He did it. So I believe Alan when he says he has sensitive eyesight. This guy who said he saw a meteor shower in 1930, I don't think so. 5th magnitude, 6th magnitude meteors on the night of a full moon with a ring around the moon. That's what this guy claimed to have seen. He saw all these meteors with high cloud cover and a full moon. Nobody else around the world saw the meteor shower. This one guy saw it. No, I don't think it happened. Sorry. I'm not going to believe that there was a meteor shower back then. Now, all of the ejected particles, regardless of size and unless perturbed, stay closely confined to the plane of the comet's orbit, at least until in time the stream degrades and drifts apart. Gravitational perturbations by the planets are a major factor in determining a meteor shower, shifting and breaking up of a meteor shower. Tracking all of these influences and factors is what a meteor shower or predicting a meteor shower is all about. Now, the average person walking on the street, when you mention meteor shower, probably thinks that a meteor shower is something like this. Whoops, hold on for a second. I can't possibly, I got it at home. I can just hit a button here, but I'm trying to start this. Oh, what do you know? It's not moving. Why is it not moving? You're blowing my best effect of the whole talk. All right, well, unfortunately, what you would have seen is the Jupiter 2 getting hit by giant boulders. A bunch of boom, 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 boom. And you know, that's what the average person thinks a meteor shower is all about. No, not true. In the case of most of the annual meteor showers, the majority of the visible meteors are caused by particles, generally ranging in size from small pebbles to sand grains and weighing less than 1 or 2 grams. Now, here we go. The question as to whether we're going to see any kind of activity this year in 2022. In 2005, there was a technical paper written by 3 individuals from the University of Western Ontario, Paul Weiger, Peter Brown, Helen Shinge, and they enlisted the aid of this gentleman right here, Jeremy Valbalion from France. And Valbalion produced a sophisticated model for the formation and evolution of comet dust trails. So for Comet SW3, numerical simulations were performed. He's got one of these supercomputers, I guess, in France to do this, using 2 million particle ejections extending from 1801, before the comet itself was discovered, until 2006. And he assumed the typical ejection velocity for sand-sized particles would be on the order of about 20 meters per second. And the result, after he did his animations and simulations, was, looking at the future, no significant number of meteoroids released during the 1995 splitting is expected to encounter the Earth in 2022. Oh, darn it! So no meteor shower, according to Jeremy Valvaillon. And I mean, who's going to argue with somebody with a supercomputer and all that information? And Valvaillon is considered to be one of the top meteor forecasters in the world today. Still, you know, it was the pandemic. I didn't have anything much to do. And so I decided, let me try and figure this out for myself. Out of curiosity, I tried to model the meteor stream associated with the breakup in 1995 of Comet SW3 by using my own computer software, an N-body integrator, which some of you may remember on the market was a DOS, a DOS disk operating system program called Dance of the Planets. Remember that, how big it was? A lot of people use that just to simply say, I'd like to see what the moon looked like when it was near the Pleiades, or simulate eclipses, but you could do a heck of a lot more with Dance of the Planets. A great tool, I found. In fact, I have a computer at home that is fairly old. It's about 15 years old. I hold on to it today because you see it's a disk operating system, and on that computer, I get to see the image of Dance of the Planets on the screen in full view. If I try to put it on my new computer, it looks like I'm watching a television show from the 1950s. Not in, it doesn't fill the whole screen. But I took the orbital elements of 20 different apparitions of Comet SW3, and I kind of squeezed them together into about a 1 million mile section and placed them at the 1995 position, and then started the computer program on its way. And each time the comet went around the sun, the pieces that followed it, that I created for it, got further away from the comet, until finally, by 2022, I would have a whole line, a meteoroid trail, if you will, of comets following SW3 through space. So this is what I ended up doing. Here's what the animation that I created. Here's the sun, Mercury, Venus. The Earth will be coming around here, and there's that crossing point between SW3, the orbit of SW3, and the Earth. So let's start everything into motion here. Mercury, he's coming around that bend right now, and here comes Venus, and here comes the Earth. Here we come, and we are approaching the May 31st crossing point, and there we are, right there. But where's the comet? The comet's not there. The meteor trail is not there. We're not going to see any meteor shower. Valvaillon was right. Patrick Galoop. Here comes the comet, and here comes the trail. In August, long after we pass the intersection point, long after we're gone, that's when the comet finally has arrived. So the comet gets there too late. We don't see any meteor shower, and that pretty much closes the book on that. At least so we thought. But the physical breakup of a comet nucleus, we just can't assume that its constituent particles are chiefly dust and sand in grain size. Instead, you get a breakup of a comet, you've got to believe that some of those pieces are a heck of a lot bigger than a grain of sand. Probably nugget-sized, maybe even rocks the size of walnuts or ping pong balls, for goodness sake, if not even larger than that. Now, how the large particles are spatially distributed. And here you see an example. No longer are we talking about grains of sand. We're talking about big rocks and pebbles. And that, I'm making the assumption, is what came out of the comet after it broke up in 1995. And how large particles are spatially distributed depends in part on the spin of the comet's nucleus and the location of the outgassing regions. As the nucleus is heated by sunlight, bits of dust and gas come loose and spread outward. And the pressure of the sun's light helps to force these particles back behind the comet. Now, the idea that light has pressure may seem strange to you, but if you hold your hand near an electric light or in the sunlight, you cannot feel light pressing on it. Nevertheless, light does have pressure, and it's only noticeable when the light becomes extremely strong, as it is near the sun, and only affects very small particles like molecules of gas or dust or sand grains. This is called solar radiation pressure. Small particles are pushed away more rapidly by solar radiation pressure, regardless of the direction they leave the nucleus. And this pressure of sunlight helps to force these dust particles to a position trailing behind the comet. This is what Balyan was assuming, that we had a normal situation of material being released from the comet and ending up behind the comet, these small particles. But particles that are larger than grains of sand are greatly unaffected by solar radiation pressure. And here was my argument for this whole thing. In a normal case, the smaller the particle, the more rapidly it can be ejected out into space from a comet, 20, 25, maybe 30 meters per second. Larger particles are heavier, and so they are shot out into space at a slower speed, 10 or 15 meters per second. But this is not a normal case. This is the breakup of a comet nucleus. And when SW3 fragmented, particles of all sizes were probably poof, pushed out in all directions at relatively high speed, in all directions. And if you got those big particles that are not going to be pushed around by solar radiation pressure, and they are out ahead of the comet, forward of where the comet is, you know what? They ain't going anywhere. They ain't moving. Solar radiation pressure can push on those big particles all they can. Nothing's going to happen. Those particles are going to stay where they are. And if they are forward of the comet, that means they're moving in orbits smaller than the actual comet itself. And the closer that an object is to the sun, the faster it must travel in its orbit. Gravity insists upon that. That's fundamental natural law. So eventually, these particles forward of the comet are going to move far ahead of the comet, and that may help out in the potential of a meteor shower for us. Remember I said in my animation, the comet got to the crossing point with its meteor trail several months after we were there, so no meteor shower. But what if, way out ahead of the comet, it's kind of like, you know, if you look down the track and you see an approaching train with its headlight or whatever, what if perhaps that train was actually pushing, or something was ahead of that train forward before the train actually got there, that something else was going to get there first? That's what I'm saying. Is it possible that we might be seeing material ahead of the comet, which would get here in time for us to see a shower on May 31st? So this time, back to the drawing board we went. Here again, the orbit of the comet. Here's the orbit of the Earth. But this time, I placed the particles in front of the comet, not behind, in front. And over time, with each time the comet went around the sun, the trail got longer and longer and longer and longer, until finally we have 2022, this month coming up. Watch now. Here we go. Here comes the Earth coming around the bend. But before we get to that intersection point, look at this. The comet coming by around the 28th, according to this calculation, and the Earth ends up between comet number 13 and comet 12. Again, I made 20 different comets to represent the comet trail. So between 12 and 13, that particular segment of the comet trail is where the Earth ended up. So then I said, okay, let me see if I could do something with that. I got the orbital elements of comet 12 and 13, and then I calculated the orbital elements for the other 18 comets. So what I made was a compression of 20 comets representing that segment of the comet orbit, which we may very well intersect at the end of this month. And I wanted to see how they were going to interact with the Earth. And here we go. This is a close-in view now of that segment, the 20 comets. Here's the Earth right here. Here's the orbit of the comet. And as we start the animation again, here comes the Earth. But wait a minute, here come that track of 20 comets, right? And the Earth is coming up to the intersection point, coming. And now we're actually interacting with, it appears, at least 5 out of the 20 comets right there. And in this simulation, which I came up with an intersection time, or a time when we would intercept that segment of May 29.74 UT, but with a margin of error of plus or minus 1.5 days. I didn't have one of those supercomputers like you know, the real astronomers or the real calculators do. I'm working with a disk operating system from the 1990s, but still it's Dance of the Planets, and still this was a hell of a great program. And in fact, I want to tell all of you, if you want, you can buy Dance of the Planets still. ARC Software, which makes this software, continues to sell it today, not at $250, which is what it cost back in 1990 or whatever it was, $75. And if you have one of those DOS emulators, you could put it on your computer and you could work with it. And I tell you, it is magnificent. I know some of you may swear with Stellarium or you know, some of the other programs that are out on the market, Starry Night Pro. To me, the best program out there still, after all these years, is Dance of the Planets. Anyway, after all of this, and with us still in the pandemic, I said, well, I've got all this great information. Now what am I going to do with it? So I spent about 11 months, you know, cobbling away every so often at a technical paper. I finally finished it. I submitted it to the International Meteor Organization in Belgium. They in turn had it vetted by a very famous meteor expert, David Asher of Ireland, who said, this is a very, very good paper. By all means, we should have this published. And eventually it was picked up by the Royal Astronomical Society of Canada. I mean, that is quite a thing when you publish a paper and another journal sees the paper and says, we'd like to have it in our paper as well. And so in 2 languages, there you see, the question I pose, will Comet Sw3 Meteors produce a meteor outburst in 2022? Well, when you write a paper like this, other people around the world, other academicians read it, look at it, and it kind of piques their interest. And indeed, 2 other papers came along. The first from Germany, The Disintegrating Comet and Sw3 Meteors by Hartwig Luthern, Rainier Alt. I hope I'm pronouncing this correctly. My wife is German, and she's going to give it to me tonight after this talk. She'll say, "You pronounced those names wrong." I'm doing my best here. I'm an Italian kid from the Bronx. Hartwig Luthern, Rainier Alt, Michael Jaeger. And in Japan, we have another paper, Sean Hori, Jonichi Watanabe, who I've got to know very well via the internet and via social media. Very nice guy. And Mikeya Sato, who's very well known in calculations. And I must tell you that Sato and Arlt, the guy named Rainier, he and Sato are first-class meteor calculators. And when these 2 papers came out, totally independent of each other, they each came up with their own calculations, again, assuming like what I assumed, that the material is forward of the comet, ahead of the comet. And again, this was, for me, I mean, this is just an assumption, because you got to figure that these big pieces, which normally would move or be ejected at 10 meters a second, they had to be ejected at about 25 meters a second in order for them to be in position to be intersecting the Earth's orbit. But these 2 teams of calculators did their own survey, and they came up with a time of May 31.206 UT. That comes out to be 12:57 a.m. Eastern Daylight Time, Tuesday morning, May 31st, as to when we would be passing closest to the trail of debris from Comet SW3. To show you how amazing these 2 teams were, they were off. The difference between the 2 different teams, they were off in their calculations, or they were the difference between the 2, 4 minutes. 4 minutes between these 2. Now, I came up with May 29, give or take a day and a half either way. I go with these guys. If I were you, I would pretty much assume that these guys are on target for the possibility of seeing a meteor display. Ah, yes, my good friend Jeremy Vauballion. You remember back in 2005, Dr. Vauballion wrote, "Ain't happening. 2022, all the meteors are going to miss us because they're going to be trailing behind the comet." And now, all of a sudden, my paper is published. All of a sudden, people from different parts of the world are reading it, looking at it, making commentary, making their own calculations, seemingly in support of what I wrote. But here's my nemesis, the guy who said it ain't happening with his super duper computer animated program, right? Well, it appears that after my paper came out, Lovejoy looked at it, went back to the drawing board, made some changes in his calculations, and then did his own little short study again of the situation. And he wrote, in 2021, Joe Rayo presented a study showing that if the meteoroids are ejected at higher velocity, they will definitely cause a meteor outburst. Rayo also explored the influence of the change of the comet's orbital elements. And in this short study, we confirm Joe Rayo's findings and go slightly further, exploring the conditions that make the shower possible, as well as the observation optimization. Merci beaucoup. Thank you. So now we have somebody who did the calculations and said, yes, it is plausible that we could have a meteor shower at the end of May of 2022, because the meteors apparently are going in all directions, as I said, after they were released from the comet. And Lovejoy, in his short study, said just how many large particles can be expected to be ejected with velocities of 25 to 30 meters per second. Typically, not many for most meteoroid trails, but the 1995 trail is unique. It was formed in the wake of a massive disruption of SW3. The required 25 to 30 meters per second that Rayo is suggesting is a little on the high side, but not excessively so. And this ejection velocity range should just encompass the required value for meteors of visual meteor size. In short, the more particles that were ejected at 25 to 30 meters per second, the greater the outburst for this meteor shower. So now the $64,000 question. How many meteors are we going to see that night? How many? Well, we've never been through this meteor trail before. Never. It's unique. We've not gone through this broken area of comet debris. So how can we get any idea, any concept of what may be going on? I tried to calibrate this by looking back at other similar situations. For example, 5 years ago, in 2017, in its orbit around the sun, the Earth passed within 102,300 miles of the debris trail left by Comet SW3 in 1941. This is what you would call the sweet spot. This is where all the stuff is. We were outside of that. And a lot of people said, well, we're not going to see anything if we're that far away from the comet. And yet, in fact, this encounter or lack of encounter produced about 5 meteors per hour in 2017. Now, that with the background there, here we go to this year. This year, 2022. Here is the sweet stuff. This is where all of the fat, if you will, or the schmutz that broke up in the wake of the 1995 fragment of the comet Nucleus is. The Earth is going to be coming right through here, crossing through this segment of the comet region, right over there. We're going to come within 35,500 miles of the center of that trail. In other words, almost 3 times closer than we did in 2017. Well, if we're almost 3 times closer, using spatially or scalability standpoint, the encounter in 2017, which gave us 5 per hour, that should give us a grand total of 14 meteors per hour. Wow. Well, not so wow. I know, nobody's known it, right? But 2 things to consider here. Number one, remember that when we saw the 5 per hour, that was from 1941 debris. The comet went around the sun 17 times before we encountered it in 2017. And that material got spaced out or spread out pretty much during those 17 revolutions. This time in 1995, we're going to be encountering the material after only 5 times around the sun. So the particles are going to be probably much closer together than they were as opposed to when we went through the 1941 debris. But here is the question. This is the big question. How much more concentrated is the dust and debris in the 1995 trail as compared to 1941? Remember, the comet underwent a tremendous expulsion of dusty material that got strewn out in all directions when the comet broke in 1995. How much more concentrated is this zone right here compared to what we encountered in 2017 when we only saw 5 per hour? And now again, scalability, proportionally, we'd see 14 per hour if the amount of debris was the same in here as in 1941, but it's not. I'm sure it's not. Let's make an assumption here. How about 10 times more concentrated? Well, if it's 10 times more concentrated, that means we would see an outburst of 140 per hour. That's pretty darn good. That's about as good as the Geminid shower in December, better than the Perseid shower in August. How many of you try to watch the Geminids? They're the best shower of the year now. We're producing over 100 media. I've done it on many a cold December night. And my teeth has chattered quite a bit on all those nights. This here, if we get 140 an hour, it's the end of May. Certainly, I don't have to worry about freezing to death. If it's going to be probably a very nice, tranquil night. Hopefully, it will be clear, we hope. But now, 140 per hour. That's pretty darn good. You're probably saying to yourself right now, where does he come in this whole thing about a meteor shower? Those of you, obviously, many of you know, this is Bob Ross, the Happy Trees painter on PBS. And by the way, if you ever have a bad case of insomnia, this guy will put you down in 10 minutes, no question. Anyway, he creates masterpieces in less than 30 minutes on his easel. And if you've watched the show, and I'm a big fan of Bob Ross, if you've ever watched him paint a picture, about half or 3/4 of the way through the painting, he gives you that little smile and looks at you and he says, let's get crazy. And right after that, he fills the whole easel with trees and mountains and lakes and there, and builds a cabin here. Let's get crazy. I use that 3-word mantra now when I'm talking about this meteor shower. Let's get crazy. Instead of 10 times more concentrated, how about we assume that that zone of material, as opposed to 1941, how about if we assume that the trail of material is 100 times greater? If it's 100 times greater, 100 times 14 gives us 1,400 per hour. Now, the definition of a meteor storm is 1,000 meteors per hour. We're talking about a meteor shower or meteor display that would be producing 20 to 25 meteors a minute. And that would be really fantastic. This would be the greatest single meteor display going back to 2001 when we had the Leonid meteors in our sky. I'm sure many of you remember that. And it'd be wonderful if we had something like this again coming our way at the end of the month. Now, a couple of things I have to note here, though. Here's a diagram of the Earth. The Earth is moving across your field of view from left to right. Speaking of the Leonids, when they come along in November, the orbital track of the Leonid meteors is coming in a direction totally opposite to the direction of the Earth. So they ram the Earth almost head on at 72 kilometers a second. So you know whether or not you're going to see a few Leonids or whether it's going to be a big meteor shower, no matter. You know that when you see the Leonids in the sky, they're going to put on a show. They're going to be bright. They're going to leave long incandescent trails. They are going to put on a very, very good display. Well, look at the Sw3 meteors. They're moving in the same direction as the Earth. The only meteors we're going to see later this month are those that are fast enough to catch up with us in our orbit. And when they ran through our atmosphere, they're only coming through at about 16 kilometers per second, 10 miles per hour. That's not very fast. And as a result, we may not see very bright meteors. The meteors that we're looking at may be relatively faint. Here's an example of that. This is the Biela meteor shower, the ones that broke up from Comet Biela in 1872. This picture may be artistic license because the majority of the meteors seen at that meteor shower were generally 4th and 5th magnitude. They were described as slow, faint, and evanescent Anybody know what evanescent is? I had to go to the dictionary for that word. Evanescent, transitory, fleeting, vanishing. So that means that if you're going to try and see this meteor shower, I would try watching this meteor display from Nepperhan Avenue in Yonkers. Nor would I try seeing it from anywhere in the 5 boroughs of New York. You have to be in a dark area. Get as dark and as far away from light pollution as you can. The dark, this might be worth a reason to go to Cherry Springs. I don't know, maybe you've been there, but if you want to go and get a dark sky, that's where you should be watching this meteor display. However, not all of them are faint. Some of them were described in 1872 and could very well be the case here as exceeding first magnitude, often appearing red with trains of orange sparks. So some of the brighter ones may indeed put on a very good show. And in fact, 10 years ago, a guy by the name of Pierre Martin, he's a crazy guy, Pierre is. You talk about an assiduous meteor watcher, he's out every night. I wonder if he's married. Well, anyway, every night he's out observing, and he was out on the night of the Sw3 meteor shower in 2011, when he was averaging like 1 meteor every 4 hours or something. But in that year of 2011, he wrote, I saw a single gorgeous Tau Hercules. By the way, when that guy who claimed that he saw all those meteors in 1930, the radiant was purportedly in Hercules. So we call that meteor shower the Tau Hercules. This meteor shower now is not in Hercules anymore. More on that in a moment. He saw a single gorgeous Tau Hercules. It was magnitude -1, golden yellow, and it left behind a thick wake. So maybe we might see a few of these that night in the sky. That would certainly be worth staying out and looking for meteors. There is what is called the typical radiant, where the meteors normally come from, at least where they assume to come from, if the material was trailing the comet near the star Tau in Hercules. But the radiant of the outburst may be coming from Boötes, not too far away from Arcturus in our sky. This is a diagram showing you the altitude of the radiant at 1 a.m. Eastern Daylight Time on May 31st of this year. Some of you may have gone to Baja California in '91 for the great solar eclipse. And if you had a good time there, maybe you might want to consider going back for the end of the month, because the radiant is going to be right up here, right over your head at the peak. Notice the concentric circles indicating the altitude of the meteor's radiant point. And here in the New York metropolitan area, we are going to be located between the 60 and 50 degree line, 55 degrees up. That's how high the radiant will be. And you know how you figure out how high in the sky that is? You make a fist. You take the bottom of your fist and put it on the horizon. The top half of your fist is 10 degrees. So if we're saying 55 degrees, that's 1, 2, 3, 4, 5.5. It's going to be way up there. That's well up in the sky, and that should be allowable for us to see a lot of meteors in this particular display if it comes. There's the star map for 1 a.m. on May 31st. And for those neophytes who don't know, you show something like this, newspapers might print a star map. People say, oh my God, well, I don't know. What is this? Where do I look? All these lines. And that's once, this is the honest to goodness truth. My friend Sam Storch, who taught astronomy at one of the colleges in New York. Somebody, one of his students, he handed out star maps. And the homework assignment was find 5 constellations using these star maps. The next week, somebody came up to his desk and said, Professor Storch, I couldn't do my homework. And Sam said, why? He says, I couldn't see those lines in the sky. True story. So the average person gets scared. They say, what am I going to do? Very easy. Everybody, I hope everybody at one time or another seen the Big Dipper, right? There's the handle, there's the bowl. Follow the handle of the Big Dipper. Follow the arc to Arcturus, the brightest, one of the brightest and the most colorful stars in the sky. Even somebody in the city, you send, look west at 1 a.m. on May 31st. Look west. Halfway up in the sky, you'll see this bright orange yellow star. And from that area, that region, that's where the apparent source of the meteors will be coming from. from all out in this direction right here. And hopefully there'll be a whole heck of a lot to see. But again, another key is making sure that it is dark on that night. And another great thing, we've got a full moon coming up on Sunday. I think something's going to happen to it later on Sunday night, but it's a full moon. The meteor shower is 2 weeks later. And 2 weeks later means that it's not going to be a full moon anymore. It's going to be new. In fact, it's one day the meteor shower comes, one day after new phase. It'll be a thin sliver. No need to worry about the moon interfering in this view of this possible meteor display. Now, as I finish off here, here's my declaration. I am excited as to see what's going to happen with this, though I have to admit I will not be holding my breath. Meteor showers are notoriously fickle, and it's possible that nothing at all will occur at the appointed time. I just finished a series of interviews this week with a number of meteor experts, asking them, what do you think we're going to see? And over at NASA, they said, nothing's going to happen. They have computer models, and they said their models say, we're not going to see a darn thing. And that's important because there are satellites up in space that they need to alert people to in case they might get hit by a meteor. But according to Bill Cook, the head of the meteoroid division at NASA, he says, we're not expecting anything major. But then he added, but then again, I could be wrong. It wouldn't be the first time. On the other hand, there's a Russian expert, Mikhail Maslov. Maslov has been doing these calculations for years, and he has been pretty damn good. According to Maslov, we will see a display of at least several hundred per hour. He said, that's what my model shows. We'll see at least several hundred meteors per hour with this shower. But then he adds, but because we're talking about the breakup of a comet, there's going to be a lot more material out there. So I think we need to up that by 1 to 2 orders of magnitude. So he says we might see as many as 10,000 to 100,000 per hour. So who are you going to believe? On this side, nothing. On this side, 100,000. You're just going to have to go out and see for yourself. And let me just say, from a historical guideline here, if historical patterns are of any guide, we are long overdue for an event such as this. Over the last couple of centuries, it seems that a new strong shower emerges seemingly from nowhere with some frequency. Particularly noteworthy, the Lyrid meteors of 1803. You know the Lyrids, 10 meteors an hour, maybe 15 an hour every year in late April. You know, not a great shower, right? But for whatever reason, in 1803, the church bells were rung in Richmond, Virginia to wake everybody up because the end of the world was at hand. The sky was on fire. It was an amazing display of the Lyrids, totally and completely unexpected, totally and completely unpredicted. And then, of course, the B-lid shower, the one that poor Flammarion missed in 1872, that wasn't expected. That was a surprise, surprise. And 1933, the Draconid meteors coming from the head of Draco the dragon up here. Here's the Big Dipper. 1933, this meteor display suddenly fired up after sunset over Europe in Portugal and Spain and Ireland. Reports of people on their knees praying because they didn't know what was going on. Nobody had expected something like this, but it happened. It was indeed a surprise. So what I'm saying is we haven't had a surprise meteor shower pop up in quite a while. Of course, now that all of you are aware of the possibility of this, it's not a surprise anymore. But I don't want any of you to run into what Flammarion did, right? So we haven't had a surprise meteor shower pop in a while. Maybe this is going to be the shot. I'm going to be outside watching that night. Will you? Thank you. Thank you very much. 9:03, 1 hour and 1 minute.
Just if anybody has any questions in Zoom, you can put them in the chat. Can you just repeat the question? Because they can't hear the meeting, the room. these people can't hear the room. So if someone asks you a question.
Sure, I'll repeat the question.
Okay.
Does anybody have any questions? Yes.
Could it be possible that you were totally right and it's really the day before?
When we have meteor outbursts, if history is any guide, like the Leonids or the Belids, these meteors tend to be crunched together very, very close. And so the Earth goes through a very thickly clustered area of material, of debris, in just a very short time. I would have to say that with the peak expected at 1 o'clock, don't expect to see very much until 11. And if it does come to fruition that we have an unusual number of meteors, expect it to be pretty well over with by 3 in the morning. It's not out of the question that you might see, let's say, the day before an unusually, bright meteor, or maybe 1 or 2 forerunners, or the day after a straggler or 2 left over. But the main show is really going to probably be concentrated within just a short time. I caught the outburst in 1969 of a Leonid meteor shower. This was 3 years after that great display they had in ‑66. I went out at 4 o'clock in the morning. I was living in Throgs Neck at the time. And I stepped outside, and as soon as I stepped outside and looked up toward Leo, I saw a Leonid. I said, oh, hey, that's 1. And I began to open up my lounge chair. Oh, that's 2. And I, got myself comfortable. That's 3, 4, 5. I started seeing meteors coming up like 1 per minute. I said, amazing, this is great, this is fantastic. 50 minutes later, zilch for the rest of the shot. And later on, as Sky and Telescope had mentioned in a survey of what had happened, we apparently ran through a thick cluster of particles, very, very concentrated, produced something like a few hundred meteors an hour in a very dark sky. But it came and it went very quickly. Very much like one of my friends, Dennis Cassia, who takes lots of astrophotographs. He said it was like somebody opened a spigot, all the meteors came out, and then all of a sudden somebody said, all right, that's enough, and he turned the spigot off. That's what probably will happen if we do get an outburst this month. It's going to come quick, enjoy it, savor it while it's happening, but then just as quickly, it's going to come to an end. Anybody over here?
In the back.
Oh, yes. Hold on, let me jostle over here for a second. Yeah. Could you pull out the mask? I mean, nobody's gonna. No, because you're right. It looks that way because it's a flat, one-dimensional. The question was that this young man mentioned. He said on the animations that I rendered that it looked that the orbits of the comet and the Earth were coming together not at one section but at another section. It turns out that other section it was not on the same plane. From where you were looking at from above, it looked like they were crisscrossing, but actually the comet or the Earth was below or above, so there was no real interaction. Actually, I think the comet was coming downhill, so to speak, and when it reached the other intersection point, that's where it was closest to the Earth's orbit. What you saw in the diagram beforehand, while it looked from that perspective like they were crossing, they really were not. By the way, that's a term that's not often used in astronomy. They call curtate orbits. And in fact, if you've seen pictures or diagrams of the orbit of Pluto crossing the orbit of Neptune, it looks like that they crisscross. They never do because Pluto's orbit was way above the orbit of Neptune. But from that vantage point, when you're looking down at the orbits of the planets, it looked like that they were crossing at 2 different points. But again, they were really quite far from each other. Way in the back. I have bad hearing too. That's why I have to.
You said the meteor shower is going to be by Arcturus, that area? Like, what area of the sky?
Near Arcturus you're talking about?
Yeah.
Yeah. The question was, will the meteors come from near Arcturus? That is the expected radiation point. Again, assuming that the meteors do come forward of the comet, that we should be seeing meteors fanning out, not at Arcturus, but several degrees to the north and west or away from Arcturus. But again, Arcturus is such an obvious a landmark or a bookmark, if you will, in the sky. So if I were telling anybody, you know, that the meteors were going to come from a specific area, I just simply say, look to the west, about halfway up. You can't miss it. Bright yellowish orange star. That's the general vicinity. But you don't look there during a meteor shower. You all know that. You're looking at the vanishing point. The meteors are fanning out from that area. So it's better you get into one of those nice long lounge chairs and just lie on your back and look up. And if there are a lot of meteors, they're going to be going every which way out from that general area of Arcturus. But again, I can't stress enough. The thing I'm really concerned about is, you know, turning on the radio, you know, the day of the shower, and you hear somebody on the news, the local news. Well, tonight you could see as many as 100 meters or more an hour in the sky. Make sure you see it, blah, 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 blah. Never mentioning the fact that you really have to probably get away from those bright lights. And that's why people always get PO'd as astronomers. Well, I was out there looking for that meteor shower last night. Maybe I saw one. Yes, and where were you? Well, I was right across the street from Walmart. That's where I live. And, you know, I see a dick, you know, no. The thing that has to be stressed is the light pollution. And by the way, it's frightening the hell out of me. I'm not going to be here. I'm going to be out west somewhere, out in the southwestern U.S., where the skies are going to be, if you know the John Bortle scale, which runs from 1 to 9, where I'm going to be located, it's Bortle 2. Now, I know it's difficult for all of you to believe, but when I was very young in the 1960s and early 70s, I had an uncle, my Uncle Ron and my Aunt Irma. They lived in Mahopac, New York. And back in those days, this is, let's say 50 years ago, when I heard that I was going to Uncle Ron's house, I'd make sure to pack my telescope, because where Uncle Ron lived, typically the magnitude of the limiting magnitude was about 6.5. And on some of the best nights at Uncle Ron's house, I could see the Milky Way, not as a hazy band of light, but granulated. Granular. It was dark, every bit as dark as, even darker probably than what people say. I've never been to Cherry Springs, but they say that's dark. But look what has happened in 50 years. The light pollution is just spreading across this country like a cancer, metastasizing. And even now, I have a dark sky atlas from 2006. It's not valid anymore. The places that were dark are not dark anymore. It's getting increasingly hard to find a very dark sky. And I don't know what's going to happen unless the IDA, the International Dark Sky Association, can do something about this in a hurry. I think that in 50 more years. Well, I wrote an article last year about the return of Halley's Comet for Sky and Telescope in 2061. 2061 should be a lot better than it was in 86. But if you remember, I finished the article by saying, so it's going to be better in 86. The big question is, are we going to be able to see it at all in 2061? Anywhere, if the lights continue to proliferate the way they've been over the last 2 or 3 decades. It's a very, very sad thing. And as you can see, it has chased me from, I live in Putnam Valley. I'm 6 miles away from where my Uncle Ron used to live. I said when I was a very young boy, I said, when I grow up, I'm going to live right up here. I'm going to live where Uncle Ron lives to see the stars in the sky. In the 20 years that I've lived in Putnam Valley, my limiting magnitude has gone from plus 5.5 in 2002, now on my best night, plus 4.5. In fact, I made a comment to somebody at the Astronomical Society of Long Island, Steve Liebler, the other day. I said, now the sky I have here in Putnam Valley reminds me of my very best nights as a very young boy in Throgs Neck. That's kind of like, you know, we're losing it. We're losing the sky. Can we do anything about it? I hope so, but it seems, in spite of all of you know, they always pat themselves on the back, the IDA. Oh, we've declared this a dark sky park, and oh, this is a dark sky park, and that's a beautiful place. Yeah, but why do I have to travel to Arches National Park to see the stars and see the sky? What are you doing about me? What are you doing about my sky? Apparently not very much, but what are you going to do? All right, rant over.
Thanks so much. Thank you. So
Okay.
we're all, for anybody who's interested, we're heading out over to Applebee's. Everyone is welcome you don't know where it is, you can follow someone. It's only about a 5-minute drive. And hope to see you at the picnic. Well, and the night before.
Before you go, speaking of ranch, could you tell us what Joe Chiappi is really like?
You see Joe Chiappi, we have, Joe and I, we are now 2 out-of-work broadcast meteorologists. And so Joe and I, we have now, we're doing shows at night on his YouTube channel, Joe Chiappi YouTube. And we do a show every night called the Joe and Joe Weather Show. We always fight over who gets top billing. And Joe, of course, was a former on-camera TV weathercaster at Pix 11. But the funny thing about that is that even though the two of us, I think I could still certainly do the job. And Joe, I know, can do the job. But sadly, in the TV world, the people who are in charge of television, all of you would much prefer to see people in the favored 25 to 54 demographic. And so even though, you know, Joe is an Emmy Award-winning meteorologist, I've been nominated 8 times for an Emmy and have gotten a number of different awards. In spite of all of that, they would rather, the TV people would say, we'd rather hire somebody who's in their 20s and 30s. Now that may sound like age discrimination, and it probably is. And they get around that by saying, oh, you don't want this job. You're overqualified for this job. You're Joe Rayo, he's Joe Chiappi, you know. And that's how they get around not hiring people who are, well, Joe is 62, and come August, I will be the big 6'6". So, like I said, I still think I can do the job. People are always doing messages on Facebook to me saying, why don't you go back to TV? We want to see you on TV again. And I tell them, I've tried. I've knocked on the door of every television outlet. I've even knocked on doors in Albany and West Hartford, Connecticut, and radio silence. So there you go. But I hope I still have it in terms of giving talks on astronomical subjects. I thank you very much.